Hello children, welcome back. So let us continue with the worksheet number 1A from work, power, energy, numericals. So let us start with the first problem, that is, when a stone tied to a string is whirled in a circle, the work done on it by the string is. We have already discussed this in the concept, children. So whenever a stone tied to a string is whirled, the centrifugal force must be acting towards the center and the direction of the displacement of the stone will be in the tangential drawn to that. So angle between the force vector and displacement vector is 90 degrees. So in this case, the work done is equals to Fs cos 90 degrees. Since cos 90 is 0, so work done is also 0. Moving ahead with the next question, children. So second one, a man with a box on his head climbing up a ladder, the work done by the man on the box is. Well, so what is the position of the man? The position of the man is moving upwards. So motion of the body in the upward direction. Force is also applied in, but force is acting on the blood in the downward direction. What force is acting? Is he applying any force? No. The force of the load is acting on his head in the downward direction. If you simply leave this load, which direction the body will move? Obviously downwards. So force on the body is acting in the downwards, but the person is climbing the steps in the upward direction. The weight of the body is acting downwards, motion of the body in the upward direction. So both are acting in the opposite direction. So in this case, the work done is said to be negative. Okay. So that is, this is the load, mass M. Here is your person. The weight is acting downwards, whereas the person is climbing upwards. Displacement is upwards, weight is downwards. Hence, work done is negative. Moving ahead with the third question, work is said to be done, statement A and statement B. A force is applied which brings about its motion. A force is applied but no motion is produced. When does a work is done? Whenever displacement is produced, whenever motion occurs, then only we can say that work is said to be done. If no displacement, no motion means work is not done. So only one statement is true, that is statement A is true, whereas no displacement means no work is said to be done. Hence, only one statement, that is first option, is true. So moving ahead with the next one, fourth question, work done is 0. When is the work done 0, children? When force and displacement of the body are in same direction, are in opposite direction, or perpendicular to each other. Perpendicular to each other means the angle between them is 90 degrees. Whenever the force and displacement, direction of displacement are perpendicular to each other, work done is 0. So option 3 is true. So moving ahead with the next question, fifth question, how much work is done by a force of 10 Newton in moving a body through a distance of 2 meters in its own direction? That means displacement is in the same direction as of the force applied. So work done is equals to F multiplied by S. Same direction means angle is 0. So work done is equals to force is 10 Newton and displacement is 2 meters. So work done is found to be 20 joules. So first option is true. Sixth one, calculate the work done by a passenger standing on a platform holding suitcase of a weight 10 kg weight. So what is the person doing, children? The person is standing on the platform. Whenever the person is standing on the platform, the displacement is 0. So whenever the displacement is 0, work done is equals to F dot S is equals to 0. Hence option 3 must be true. So moving ahead with the next question, that is seventh one, which of the following represents joule? So joule is the unit of work done, children, where work done is equals to force into displacement. So work done is either measured in joule or Newton meter. Okay, this is in SI system. Hence the correct option is Newton meter. Dyne also we can measure in CGS system whenever it will be in centimeter. So dyne centimeter can be true, but dyne meter is not true. That will be in CGS system. But as it was asked in joules means SI system. SI system means only Newton meter you have to consider. Number of ergs contained in 1 joule equals to, we already solved this, children. So 1 joule is equals to 1 Newton meter, which is also equals to, Newton means force, force means mass into acceleration, mass is kg, acceleration is meter per second square multiplied by meter. So this is equals to kg meter square per second square. But the same if you want to convert in CGS system, 1 kg equals to 1000 grams, 1 meter is equals to 100 centimeters, so 100 centimeter whole square upon second square. Therefore, the value of 1 joule is equals to 1000 grams into 100 square is 10,000 centimeter square upon second square. Or the value of 1 joule is 1, 2, 3, 4, 5, 6, 7, 10 power 7 gram centimeter per second square. If kg meter square per second square happens to be joules, then gram centimeter per second square will be equals to ergs. Therefore, the value of 1 joule is equals to 10 power 7 erg. The correct option is option 3, that is 10 power 7. So now moving with the 9th question, children. A body gets displaced through a distance of 5 meters. What is the displacement? 5 meters. Under the axle action of a force, how much force? 10 Newton. Displacement given, force is given. Acting at right angles to the displacement, theta is 90 degrees. Work done will be, so work done is equals to F S cos theta. So W equals to F is 10 Newton, displacement is 5 meter, and cos theta, right angles means 90 degrees. So 10 into 5 is 50, cos 90 is 0. Therefore, work done is 10 into 5 into 0 is 0. So answer is third option, that is 0. Moving ahead with the 10th question, children. How much work is done when a force of 2 newtons moves a body through a distance of 10 centimeters in the direction of force? So work done is nothing but F dot S. So this is nothing but 2 Newton multiplied by 10 centimeters. This is in SI system and this is in CGS system. All options are in SI system. So let us convert in SI system. So centimeter to convert in SI system meters, we have to divide it with 100. So 1 0 gets cancelled. Therefore, the value of work done is equals to 2 by 10 Newton meter, or the value of work done is equals to 2 by 10 is 0.2, and Newton meter can also be written as joules. So 0.2 joules. So last option, fourth, is true. So now moving with the next question. If the work done by a force in moving an object through a distance of 20 centimeters is 24.2 joules. Work done itself is given, W equals to 24.2 joules. And distance moved is given as 20 centimeters. And options are in SI system. So convert in SI system by dividing with 100. So this will give you a value of 2 by 10 meters. Or 0.2 meters. So what is the magnitude of force? So children, as we know that W equals to F dot S, the value of F equals to W by S. What is the value of W given? 24.2. Value of S is given as 2 upon 10. This is equals to 24.2. This 10 carried upwards means multiplied by 10 upon 2. So cancelling here, we have 2 goes 12.2 times, and hence the final answer is 122 Newton. So what is the final answer, children? Sorry, small correction here. Yes, sir. So 2 cancels by 12.1. So 12.1 multiplied by 10 is equals to 121 Newton. So option 3 must be true. So children, moving with the last question, that is 12th question. A body at rest has a mass 10 kgs. What was the condition of the body? Rest condition. Mass is 10 kg. It's moved by a horizontal force of 5 Newton. What is the force given? 5 Newton. Then the work done by the forces. Generally, we know the work done formula is F dot S, where the value of force is itself is given as 5 Newton. But what about the displacement? The value of displacement is unknown, whereas the mass of the body is given as 10 kg and time is given as 8 seconds. So, depending, using the kinematic equation we have, S is equals to ut plus half at square. Earlier it was given that the body is at rest condition. Whenever the body is at rest condition, initial velocity is taken as 0. 0 into anything will be 0 plus half. Where is the acceleration, children? The value of acceleration is unknown and time itself is given as 8 square, that is 8 into 8. So first of all, let us try to find the value of A and then come back to it. So what is the value of A, children? We know the formula for F as ma. This implies the value of A is equals to F by m, or A is equals to, what is the force given? The value of force is given as 5 Newton and the mass is given as 10 kg. So cancelling, we have 1 by 2. So acceleration of the body is 1 by 2. So substituting same, we have 0 into anything is 0 plus half. Acceleration taken as half, 8 times of 8. So further solving gives 2 goes 4 times, again this 2 goes 2 times. Therefore, the value of S is taken as 0 plus, this is 1 into 2 into 8 is 16 meters. The displacement of the body is found to be 16 meters. If force is 5 Newton and displacement is 6 meters, then the work done by the body is equals to W is equals to F dot S, which is equals to 5 times of displacement is 16. So 6 5s, 33, 5, so 80 joules. So the correct option must be option 2, that is 80 joules. With this, we have finished with the worksheet number 1A from the same chapter, children. So let us keep practicing and let us meet in the next video. Until then, take care. Thank you.